All right, transformations of linear and absolute value functions. This first slide I have titled vertical translation. The word vertical means up and down, okay? Translation, if you remember from geometry, means to shift or slide. So this slide, oddly enough, this slide is about taking a graph and shifting it up or down. That's what we're doing here. I've given you f of x equals 2x minus 2, and I graphed it for you, f of x equals 2x minus 2. Do you notice how my notes are colored? I have the first example is red and the next one's in blue. I will be doing the work in those colors and the graphing in those colors, so it's color coordinated. If you would like to take notes in color, just follow my lead. If not, no big deal, okay? Just telling you, sometimes I think the color helps. We have been asked to find and graph, that's two different things, find and graph f of x plus 3. It says call the new function g of x. So when I graph it, I'll put a g on it. You see how this one says f of x? When I graph that new one in red, it'll say g of x, because that's what I've been told to call it. All right, so let's see if we can do what we did yesterday. It says f of x plus 3. Have I changed the inside of the parentheses or outside of the parentheses, class? So remember, if I say class or something like that, when I'm asking you guys, I'm asking for a whole room of voices, including my home people. I'm asking for voices because I need information. I need data. How many of my students can tell the difference between inside and outside changes? So let's try again. Class, is that an inside change or outside change? Outside change. The plus 3 is clearly outside the parentheses. If it's an outside change, see if we can remember, is this going to be changing my x's or my y's? Mixed bag of answers from the 2 or 3 people who did answer, and that's okay. When you change the outside, you're changing the y values. The reason we know this is because, well, where is the x? It's inside. Since the x is inside those parentheses and my plus 3 is outside the parentheses, I'm not changing my x's, I'm changing my y's. Let's go ahead and find it. Let's figure out what f of x, and I'm going to do this part in red, plus 3 is. It looks to me like this part, the left side, has a plus 3 on it that wasn't there before. So my job is to make sure that plus 3 ends up on the far right of both sides of the equal sign. If you do it to the left, you better do it to the right. I'm hoping that the color coding is making a difference. I've stuck a plus 3 here, so I did it here also. That's what we just did. We can simplify this, we can clean it up, and we'll do the whole thing in red because I'm going to graph it in red. 2x, negative 2 plus 3 is positive 1, and we were told to call this g of x. Yesterday, I can't remember if it was this period or the period after, but someone asked me, would I keep writing f of x plus 3 and things like that, and I said, you will for now, but soon we'll give it its own name. Now it has its own name. Remember, that letter is just the name. We're going to graph 2x plus 1. It's a straight line. Its y-intercept is positive 1, and its slope is 2, technically, over 1. So you go up 2, right 1 from this dot. So up 2, right 1, give you a nice big fat dot, and then to the best of your ability, draw a straight line through all of those. I'm going to cheat because it makes good notes, but I have a straight line tool. That, oh, that's the wrong color. My apologies. That is G. I'm not even going to write the of X. That is G. Huh. Look at how those two graphs are related. It looks to me like this y-intercept went up 3 places. How about that? Putting a plus 3 at the end, outside the parentheses, made the y values go up 3. Interesting. Now we've been asked to find f of x minus 2 down there in blue. Again, the only part that's new is the minus 2. So it's almost like I'm asking you to do this, minus 2 here. So if you subtract 2 on the left, you had better subtract 2 on the right. That's what you're about to see me do. So here's the f of x, and here's the minus 2. Here's what f of x equaled, and here's the minus 2, happening on both sides of the equation. We were told to call this one h of x. You can't use g again. G's already been used. You can't use f again because f has already been used, so you're just going to call it h. It's just its name. And again, on the right side, you're just going to combine your like terms. The negative 2's at the end become a negative 4. Like that. And I will graph h in blue, so it's all color coordinate matches. H's y-intercept is negative 4. That's down here. Hey, look at that. The y-intercept went down 2 from the black graph. Wow, putting a minus 2 made me go down 2. Slope is still 2 over 1, so up 2, right 1. Let's follow the pattern. Connect your dots to the best of your ability. And this one is h. There you go. So it would appear as though adding a number outside of the parentheses makes you go up. Subtracting a number outside of the parentheses makes you go down. And that is exactly what it does. It's exactly what's happening. Adding a number on the outside makes you go up. Subtracting a number on the outside makes you go down. Would you like to ask me anything about what you see here before I give you the general rules? Because the general rules are all letters in function notation form. No? Okay. Up and down, shifting up and down is pretty much the one that everybody gets. So what is the general rule? The general rule is, oh, and you'll notice my general rules are also the same colors. So f of x plus k, where k is any constant term, any number. So f of x plus 5, f of x plus 10, f of x plus 27, whatever. Anytime I add something outside the f of x, the general rule is that shifts the graph up that many units. So f of x plus k shifts my graphs up k units. So what you did here was you transformed an equation and a graph. So if plus k on the outside shifts graphs up k units, then minus k is going to shift graphs down k units. Those are your first two transformation rules, shifting up and shifting down. And I don't think they're too groundbreaking. And you should have learned about them in Algebra 1. Do you remember it? Probably not. That's okay. That's what we're here for. Still, everybody still comfortable? Okay. Transformations are the beginning of your year. You want to make sure that the beginning of your year goes smoothly. So be asking lots of questions if you have them. I'm serious. Can I clear? Anybody panic if I do? No? Okay, no screams of terror, so we will move on. This slide is called horizontal translation. Well, we know that translation from the last slide means to slide. Vertical is up and down. Horizontal is left and right. A trick that one of my students told me some years ago, if you can't remember which one is which, imagine the horizon, how it looks left and right. Horizontal is left and right. This student told me that, and I was like, oh, I like that. So I also think of it like this. That's how I used to remember it. Horizontal is left and right. That's just me. I have given you f of x equals the absolute value of x minus 1 as an equation, and I gave you its picture as well. We are going to find f of x plus 3 just like you did in the homework. And after we have the new equation, we'll call it g of x, and we'll graph it, and we will see what happened. So I would be looking for, you know what, I'll get to that in a second. Let's go ahead and find it. F of, and now I have put something in the parentheses that was not there before. And you notice I'm not just doing plus 3, I'm doing x plus 3. I'm treating x plus 3 as a brand new thing. Where I used to have an x, I would open a set of parentheses, and I would drop in x plus 3. This is one of those times where the parentheses actually didn't do anything. They're not necessary. But I use them every single time just in case. See, if you use them every time, you'll never get caught when one of those times you needed them and you forgot. It's kind of like a seatbelt. You don't put the seatbelt on every time because you know you're going to crash your car. You put the seatbelt on just in case it was going to happen. Parentheses are the same thing. You use the parentheses in case they were necessary, and then when they weren't necessary, you go, okay, well, I didn't need them. And this is red, correct? Yeah. So this is going to be g of x equals the absolute value of x plus 3 minus 1. And that's finished. You can't do anything else. Those absolute value bars can't do their job because there's not a number inside there. It's an expression, x plus 3. So that's it. We have to graph that. And remember, one of the very first things that we did this year was review how to make point trees. So we can grab this. But before we do make our point tree, what I would like is a volunteer for this one, someone who's not afraid to help me out, someone who's not afraid to be wrong sometimes in front of others to tell me what they predict will happen. I put an x plus 3 on the inside. Anybody want to take an educated guess at what they think is going to happen to the graph? This is also how I learn you guys' names. So, Junior? Well, okay. So you're trying to tell me what you think is going to happen to the equation. What I'm saying is, what do you think is going to happen to this graph? See, on the last one, I cleared it already. But on the last one, this plus 3 here made my graph go up 3. So 1, 2, 3, and it looked like this, right? What I'm wondering is, educated guess, this minus 1 right here is this minus 1 right here. So it's already, the original one has already been moved down 1. Well, I don't think you understand. Let me be more clear about my question. This is my fault. Here's what I'm saying. This graph is this graph that's here, right here, okay? I've only changed one thing about it. I've changed this stuff in here. So did I change the inside or the outside? The inside, yeah. So if outside changes change my y's, my inside change is going to change your x's, exactly. So what I'm asking is, what do you think is going to happen to the x's? Physically, if you could put your hands on the graph, something's going to happen to the x's. They're going to move somehow. I'm just wondering, can you make a prediction on which way it's going to move? And your evidence for saying to the right would be, why do you think to the right? Because it's plus 3, right? And thank you, Junior. And you know what? I would have thought the exact same thing. And in fact, I did think the exact same thing when I was a student. But that's not what's happening. Thank you, Junior. Appreciate you. Here is what's happening. Let's make a point tree real quick. First things first is vertex, right? The point in the middle. The vertex is always found the same way. The x value is found by telling me what makes the inside equal 0. So what would I have to plug in right here so that the inside would equal 0? -3. The y value of the vertex is always found by the number to the far right, which is going to be this number. So our vertex is at -3, -1. There's not a fraction in front of the absolute value bars. So when you go to find your next x's, you just go up 1 and down 1. And you plug those in to see what your y value would have been. I'll do that in black. So the y value would have been the absolute value of, I'm plugging in the -2. Using our PEMDAS rules, -2 plus 3 is +1. Now you can take the absolute value of that 1 And you end up with 0. And the y values have to match because the graph is symmetric. Let's plot those bad boys. -3, -1, that's right here. And then my zeros are there and there. This is G. So what happened to the black graph? Which name, sir? Nick, yeah. The reason why I moved 1 left and right is because there wasn't a fraction in front of the absolute value bars. If there was a fraction, then you would have moved left and right by whatever number was on the bottom of the fraction. So it's like a slope thing, if you want to think of it like that. So if there was a 1/2 on the front of that absolute value bars, I would have moved by 2s. If there was a 1/3, I would have moved by 3s. Things like that. That's just because I'm trying to avoid having to graph decimals. Yeah, it's a good question. But while I got you, Nick, if you could put your hands on this black graph, what would you have to do to it to make it land on the red graph? Which way would you have to move it? Yeah, it shifted 3 units to the left. But Junior thought it was going to shift to the right because of the +3. And I thought the exact same thing. Now, you know what happened? It's almost like it did the opposite of what you wanted it to do. Strange. Huh. Okay. Let's go ahead and find the next one, which is fill in those parentheses with an x minus 2. We're going to drop in an x minus 2. And once again, this is one of those times where the parentheses weren't necessary. We've been asked to call this one h, so its name is h. We don't need those parentheses. They did absolutely nothing for us, so no harm, no foul. And we're going to do the exact same thing we did a minute ago. We need to create a point tree so we can graph this thing. Our vertex is found the same way every single time. By telling me what number makes the inside equal 0, what would I need to plug in? I know at least, I think that was Junior, knows. Remember, guys, I'm looking for lots of people to answer me so I know if my class is getting it or not. What number would I have to plug in the inside to get 0? Still only getting like 2 people answering me. Is it because you don't know? Is that the problem? Because I don't know if you don't know, if you don't say anything. All right, well, I'll just have to do my best, I guess. 2, it's positive 2, because 2 minus 2 is 0. The y value is always found by asking yourself what number is written to the far right, and that's a -1. And by that I mean outside. Notice how the outside numbers end up being the y value of the vertex? It's not an accident. Outside things are y's, inside things are x's. Again, because there's no fraction on the front, I am going to move up 1 and down 1. And I can plug in either one that I want. I like to go to the right, so I will plug in x equals 3. There's me plugging in the 3. 3 minus 2 is 1. And look at that. It's the exact same statement from before. Absolute value of 1 is 1. And I'm getting zeros. So we're going to plot those dots. Where was it? 2, -1? That was right here. And then 0 here, 0 here, and this one was h. So look at that. Which way did the black graph move to become the blue graph? It moved to the right. It moved to the right too. So putting the +3 on the inside moved me left 3 when we thought it would go to the right. Putting the -2 on the inside made me go to the right 2 when it kind of seems like that would go left 2, right? Correct, I mean? It's almost as if inside changes are the opposite of what you wanted. But the outside changes that we saw on the last slide did exactly what we thought they would. +3 moved me up 3. -2 moved me down 2. So outside changes did exactly what I thought they should. And these inside changes seemed to do the opposite of what I thought they should. Isn't that interesting? So before I give you the general rules, are there any questions about the graphing process, questions about the finding the new equation process? No. Crickets. Okay. All right. I'll go ahead and tell you that this stuff right here, the shifting left and right, I put the exact same question on all 6 of your upcoming chapters 1, 2, and 3 tests. The exact same question. I don't even change its numbers because I'm testing whether or not my students can appropriately plug something in using parentheses. The rule, if you put a plus H, notice this time I changed it to an H. If you put a plus H next to the X on the inside, so now the inside says X plus H, we thought it would move it to the right, but it didn't. It moved us to the left. So this is going to move you left H units. So adding something on the inside moves you left that number. Subtracting H on the inside would move you right that number. So the outside changes were exactly what they thought they should be, and the inside changes were the opposite of what we thought they should be. Interesting. Yes, what's your name? Tawny, what's up? See, so Tawny says she thought that plus, just like Junior and just like me when I was in school, should have moved us to the right. But it didn't, did it? I mean, that's why we do these point trees. That way you don't have to just take my word for it. I didn't make it up. You know, I mean, if you plug in x equals -3 right here, where I'm at, if you plug in -3 right here, you get -3 plus 3, which is 0, and 0 minus 1, which is -1. So you would end up with that, oh, not on my pen. You would end up with that vertex. And if you saw me plug in 2 and I got a 0. So it's wild that adding 3 on the inside moved it left 3. But on the previous slide, adding 3 on the outside did move you up 3. It's because inside changes do what we want, but outside changes do the opposite. I'm back. Strike that. Reverse it. My apologies. Outside changes do what we want, like we saw on the previous slide, but inside changes are doing the exact opposite of what we want. Okay? And the cutesy little way that I try to help my students remember that Y changes do what we want, but X's don't do what we want, I think about it like this. Your ex-boyfriend, your ex-girlfriend. They're probably your ex because they didn't do things you wanted, right? How about that? See, X's don't do what we want. They do the opposite of what we want. That's my cutesy joke. Sorry. The camera didn't track me, folks. I'm sorry. I didn't mean to be off frame for so long. Any more questions on it, or you okay? Ready to maybe do some practice? So I think the next slide is some practice, I think. I can't quite remember. Let's find out. Ah, good. Practice. We have f of x being 2 absolute value of x plus 1. We're going to write a new function, g, we're going to call it g, whose graph is a translation. That means shift. So maybe think of translation means shift. 3 units down. So let me ask you guys a question. If I'm moving something up and down, is this a vertical change or is it a horizontal change? And lots of people would be great if you could tell me up and down, vertical or horizontal? Vertical, fantastic. So vertical changes up and down. So I'm doing this. Is that going to change my x's or my y's? So only 2 people answered, and they said the exact opposite things. Now, the next person that's wrong, I'm going to hit with these sticks. Kidding, obviously. XY axis. Which one is the up and down axis, the X or the Y? The Y. So if you're making a vertical change, you are changing your Y's. All right? So vertical is Y changes. Now, the next question then is, if it's a Y change, would I be changing the inside of the parentheses or the outside of the parentheses? And it'd be great if lots of people spoke because it's okay. So am I changing inside or outside, class? Wow, okay, lots of people said the right answer. Outside is the correct answer. Because because x's are on the inside. If I said I'm changing the y's, I'm clearly making an outside change. So if I say an outside changes, do outside changes do, which are the y changes, the same thing we want or the opposite of what we want? Lots of people? Same thing we want. So if it says 3 down, what would I expect to see outside the parentheses? -3. So the rule, the function notation rule, would be f of x minus 3, just like that. This is where you ask me questions if you have them. I imagine there's questions because lots of people didn't know what I was talking about. And this is the kind of stuff that you're going to have to be able to do in your homework, so it would be great if you could fire some of those questions at me. Okay, all right, that didn't work. All right, well, crickets again. So we've been told to find g. That means we have to use f of x minus 3. We have to actually do it, and then we can call it g. So we take our f of x, and we stick a -3. It's like I put a -3 right here, right? And if I put a -3 on the left side of the equal sign, I have to put a -3 on the right side of the equal sign. We've been told to call this thing g. So g of x is. And on the right side, all you can do is combine your like terms. That +1 and that -3 back there become -2. So 2 absolute value of x minus 2. And you're finished. That g of x, 2 absolute value of x minus 2, is 3 units down from the f of x that I gave you. This is where you ask questions if you have them, guys, because this is what you're going to be asked to do in the homework. Okay, it frightens me no one's asking questions about transformations. Okay. Oh, by the way, I was unaware of it, but my phone was not telling me that I had people sending me reminders last night. I missed like 6 messages, apparently. I don't know why. So maybe I need to reboot my phone or something, like shut it down or something. I think what I'll do is I'll just make checking remind a habit like I do my emails, since it's not notifying me for some reason. And yes, my notifications are on. It's just decided to stop telling me that I even have a message. So I'll just start checking remind like I check my emails, just constantly. Every time I touch the phone, I'll be like, let me check remind, let me check remind. Okay. If you send me a remind and you're not getting a reply, don't hesitate to send me an email, because I check my emails constantly, and email is never broken for some reason, but remind is broken all the time. I actually sent their people an email one time, and I was like, why does this app keep doing this, and I keep missing messages? And their response was to delete it and reinstall. I did that, and it didn't fix it. So maybe it's my phone. I don't know. So like I said, send me a remind, and if I don't reply to you, I'm sorry, my phone sucks. Don't hesitate to send me an email. It's not going to bother me, okay? We've been asked to find a function h, whose graph is a translation, which again means shift. I'm just going to go ahead and write shift 2 units left. So let me grab handy dandy student beaters. There we go. All righty. Nobody even chuckled. It's okay. Left and right. Which axis is left and right? The x-axis. X-axis moves left and right. So I'm clearly changing my x's. My question to you is, would my x change be on the inside or the outside? Inside, because, well, the x's are inside. They're inside a structure. So x changes are inside changes. And then the last question, class, do x changes do what we think they should, or the opposite? Opposites. Everybody remembers that one because of the funny x, that's why they're x's joke. It does the opposite. So if it says left 2, what are we going to, because we've already said it's going to be on the inside, what are we going to see on this inside if it says left 2? Just shout out, guys. 2, 3 people said plus 2. Wow. Yeah, it's plus 2. So is this what I write? X plus 2. You have to say the X. So no, we're going to plug in X plus 2. What's new on the inside? Yeah, the plus 2 is new on the inside, but we're replacing X. 100% replacing X with X plus 2. So where we had an X, we're going to get a set of parentheses now. 2 absolute parentheses absolute. Is this a plus 1 out here? I can't remember. Plus 1. Thanks. We are going to fill those parentheses with X plus 2. We have been told to name the new one H. And on the right side, this again was one of those times where those parentheses just didn't do anything. So we don't need them. We'll just not write them anymore. Be in the habit of using them every single time and then asking yourself, was it necessary? And you're finished. There is nothing else you can do. You can't distribute a number to the inside of absolute value bars. They're kind of like jail bars. Nothing's going in and nothing's getting out. Okay? That number, that 2 that's on the outside doesn't get to play with the things on the inside. This is finished. This graph of h of x, even though you can't see it, is 2 units left of the f of x that we started with. This is what you're going to be expected to do in your homework. You're going to be expected to find new equations. It models my homework. My homework models my notes perfectly.